Good evening, everybody. Welcome to our Digital Leadership Series event featuring Sean Taylor from Lyft. I'm delighted to welcome all of you. My name is Vijay Gurbaksani. I'm the Director of the Center for Digital Transformation. Let me tell you a little bit about the center in just a minute or so. We were founded in 2012, and our goal at the business school at UCI Mirage was to help incumbent companies in particular adapt to a more digital world. And the leadership, in fact, the tagline for our business school is developing leaders for a digitally driven world. And over the last 9 years that we've been around, sort of the scope of responsibilities for all managers all the way from entry level to the top around digital transformation have become more and more complex, more and more profound. So from challenges like cybersecurity to building new business models for a digital world, these challenges are front and center for managers throughout companies. Before I get started, I would just like to make a couple of housekeeping announcements, and I'll introduce Sean and the subject for today. Number one, we're going to be using the Q&A feature, not the chat function. So please list your questions. You type them into the Q&A option on your screens, and I will moderate. The first 20 minutes or so are going to be Sean presenting a talk. I'm going to talk to him for the next 15 or so minutes, and we'll turn it over to the audience. And we'll be taking questions, like I said, from the audience. And the last thing, and probably the most important, not the most important, one of the most important things is I would like to thank KPMG and Kalpana Ramakrishnan in particular for supporting this series. We bring these series to the community as a university. Our goal is to educate not just the students who go here, but also sort of our surrounding community. So with that, thank you KPMG for making this event possible and for allowing us to offer it on a complimentary basis to all of our attendees. With that, let me turn to sort of the subject for this evening. One of the most sort of challenging aspects around leadership in a digitally driven world has to do with managing data-driven organizations. We've all heard the overused metaphor of, or analogy of data is the new oil, which I think is a little bit tired and a little bit overused and doesn't begin to reveal the complexities of what it really means to be a data-driven organization. It's a raw asset, and running a data-driven organization is quite different from the way we used to do it in the past. With that, we're extremely fortunate to have Sean Taylor of Lyfts speaking to us. I've known Sean since he was a doctoral student at NYU at the Stern School of Business. And he was one of the first doctorates to actually go into practice and built an expertise in data science. He spent 7 years at Facebook leading a statistical team, and now he's at Lyft leading a team called Rideshare Labs. What's interesting about, as you might imagine, all of us have taken services like Lyft, and as you might imagine, there's operational optimization that we have to do on a day-to-day basis in our companies, but there's also long-term and riskier initiatives that we need to invest in. And Rideshare Labs is the data science team which Sean heads, which focuses on sort of riskier, longer-term initiatives. So with that, let me thank Sean for spending his time with us. I know he's an incredibly busy schedule, so very appreciative that he's taken the time to spend educating all of us today. So with that, Sean, thank you so much for joining us, and take it away.
Thanks, Vijay, for the great introduction. Really happy to be here. Excited to talk about data science. I'm particularly excited for the questions. I think usually the prepared content always pales in comparison to the great questions that people always have. So looking forward to that. I have a little bit of prepared material, and I'm gonna talk through some slides. And my main goal here is to sort of motivate some of the work that we do at Lyft in the data science space from the perspective of what are our business problems? What are we really trying to solve? And I hope that will sort of help illustrate how we're actually solving problems, why the data is useful, and how it makes the business better to have a team of data scientists. I mean, we have over 200 data scientists at Lyft, and they all work really hard. What are they all doing? I think I'm going to help you answer those questions a little bit better. And then maybe we can talk a little bit about like what do we need to do as an organization to facilitate their work. So I'll first start with the hardest part of any presentation, which is sharing my screen. So Lyft's ride-sharing business is a two-sided marketplace. We've got demand that's growing. Well, it was growing until COVID, and it's growing again now that we're recovering from COVID. Mostly driven by organic adoption of our product as a substitute for taking cars, and also by transit sometimes. And then we have growth of supply, which is the other side of the marketplace, which are our drivers who either are full-time drivers or want a place to earn flexibly using an asset that they already own, their car. And what we're trying to compete on generally is just sort of like provide a value proposition in terms of convenience, time savings, and price for the in-car experience. And then for drivers, the earnings and the flexibility that they're able to achieve on our platform. So that's the goal of Lyft and our ride-sharing business in particular. The core problems that we run into in running this are basically growth. Increasing adoption over time is important. We need a large marketplace is better because it has more density, which means we're more likely to be able to match riders to drivers quickly. It's also better for the business because we do more volume. And so we have to do that by adding new features, promoting the product, or using incentives of various kinds. We'd like to produce good experiences for everybody who uses our product. So anytime a driver cancels on you or something like that, we'd have to make sure that happens a minimal amount of times and that we respond to it with good customer service. We want to run the marketplace very efficiently, which means making sure that we make a small number of mistakes in terms of how we match riders to drivers, how we route people to their destinations, how we do navigation. And anything that could contribute to sort of a negative experience needs to be mitigated as much as possible. And then finally, market balance, which I'm going to talk about in a little bit more detail, which is ensuring that we have the right amount of drivers for the marketplace. Too many, and the drivers sit around and don't have anything to do, and they don't make enough money. And too few means that people wait a long time, and it's very difficult for them to get a ride. And so we have to sort of form the right balance of how many drivers that we want to have in the marketplace. So starting with that market balance idea, here's a diagram that I think illustrates like a very simplistic causal model of Lyft's business. So we have sort of like our drivers showing up, and the sessions are what we call it when a rider requests a ride. And drivers plus sessions equal rides. They kind of contribute toward creating a place where, when the rider gets matched to a driver, that's a ride. Incentives are how we increase the number of drivers on our platform in the short run. So we can provide drivers with bonuses or other kinds of incentives to show up and drive for the day. And this is our main tool for improving the number of drivers on the platform and addressing the market balance issues that I described. And then drivers and rides combined to create like a rides per driver metric, which is basically like how much they're going to earn. So a notion of like whether they have enough rides for each driver we have in the marketplace. And then also a sense of like, there's a sense in which having more drivers helps produce future sessions for the platform and retention by helping ensure that we have good experiences for all the people requesting rides. So a super simple model, but it covers one decision variable, which is our incentives, something that we don't control, which is sessions, and then the outcomes that we care about, which are short-term rides and rides per driver, and then this like future sessions idea, which is our long-term value that we're creating. So we call this incentives effect on drivers a lever. Levers are a generic concept we'll talk about in a second, but it's something that we can control, which is why we call it a lever. And then how drivers and sessions turn into rides, we call a production function. It's sort of like, just like in standard economics, you have these inputs and you put the inputs into the production function and you get your outputs. In this case, it happens to be rides. So levers have this sort of diminishing marginal return shape to them commonly. So we spend money, that's what happens on the x-axis here. And then on the y-axis, we get some incremental benefit in some usually non-dollar terms. So we put money in and we get something out. In this case, it's more drivers on the platform that day. It's a very generic concept. We spend money on lots of things to generate these incremental benefits that have some sort of like theorized relationship to the success of the business. So driver incentives, coupons for riders, even things like staffing airport pickup locations that we might pay people to go and help people find out where the Lyft rides are at the airport. And that's the thing we can spend money on. And that actually does produce a benefit. And we would like to know sort of like whether the incrementality of that benefit is worth the cost. Even something like a car maintenance program for drivers. So we could give them like discounts to get their car serviced, and that might help them stay on the road or drive more safely. The production function is what creates the actual value. So we put drivers in, and then for varying levels of sessions, we'll get different numbers of rides. And this also has a diminishing marginal return kind of shape. And so knowing this shape properly helps us basically convert incremental drivers into incremental rides, which may be our goal. And so the production function tells us how efficiently we're able to make output out of our inputs. It also tells us, it's also something we're constantly trying to improve by improving the efficiency of the business. So by shifting the production function in various upward means that we're actually getting better at matching drivers to riders. So everything I just told you, I think, sort of is enough to derive almost all the ways in which data science can improve Lyft's business. And it's actually mainly three main ways. In the first category, we have forecasting. So knowing how many sessions we're going to have in advance helps us figure out how many drivers we're going to need. And so we spend a large amount of time making sure that our forecasts are accurate so that we're able to kind of figure out what the optimal level of drivers should be. Number two is improving lever efficiency. So by using machine learning models and algorithmic targeting of incentives, we can actually shift this curve upward, and for the same amount of spend on incentives, achieve a higher number of incremental drivers. And so that's a whole other pillar of work, is basically like taking all the levers at Lyft and making them work more efficiently through machine learning usually. And then third is directly improving the production function. So for the same number of drivers and the same number of sessions, can we make more rides? And that means making sure that we match more efficiently, that the drivers are positioned more effectively, that we make better decisions about dispatch and pricing. And so this is like mostly the algorithmic changes that power the marketplace. So our forecasting capability, it mainly relies on seasonality and growth models that capture sort of like how demand and supply vary according to weather and holidays, even things like school and work schedule, our market saturation, competition, and price levels. And then there are also things that we have to put in the model that are not reflected in historical data, things like manual overrides. Like we might know that a very famous example is Amazon has a holiday party coming up in the Seattle area. We have to know about that and make sure that we have enough drivers on the road. And when we build out a forecasting capability, we also have to make sure that the forecasts stay accurate over time. So it's an important kind of component of forecasting to ensure that not only was your forecast good today, but every forecast that you make moving forward over the next year are similarly accurate. And they do tend to depreciate in quality over time without kind of active tending to like where they tend to make mistakes. On the lever efficiency side, we spend a lot of time developing experimentation strategies for randomly deploying different treatments. So in the case of driver incentives, we might give some drivers incentives randomly in order to understand the causal effect of those incentives on their propensity to drive. And then we would use machine learning in order to discover the heterogeneity and the effects of those incentives. And in this case, better machine learning models through, say, improved features or complexity of the models would directly drive better efficiency for a lever. These tend to be non-real-time systems. So things like we can deploy coupons every week or incentives every morning, and it can be done in batch. So it's a sort of like lower level of reliability needed than some of the other algorithms that drive the marketplace. And then on the production function or algorithmic side, these are decisions that we're making in real time, 24/7, as we run the marketplace in all 74 regions that we operate. And so there's two main ones that I want to talk about. First is pricing. So we have to decide on a customized price for every session, millions of times per day, based on the conditions of the market, where the ride's going, where it's originating from, the time of day, all go into the pricing algorithm. So there's sort of like a complex balance there, finding the right price, making sure that we meet all of our costs, that the driver's paid properly, and that we can become profitable. We have our dispatch algorithm, which is responsible for matching available drivers to the ride requests that are made. And so between those two algorithms, we are driving the marketplace. We're sort of like making all the decisions that coordinate where the drivers are driving to, who they're picking up, and where they're dropping off. These are complicated machine learning powered systems with a lot of heuristics baked into them, but also machine learning models to help estimate some of the important quantities that go into the decisions. They have heavy upfront development costs, very high reliability requirements, and they need to be monitored constantly because any mistakes that they make are going to directly translate into loss for the company. And then finally, as we start to develop better algorithms, we actually need to decide when is a new algorithm better than the old algorithm that we were running. So if we make a change to our pricing system or a change to our dispatch system, it's important for us to be able to validate that that was a good change. And to do that, we run marketplace experiments. So almost every change we make is going to be tested in a live environment in some way in order to verify that it's making an improvement. And these marketplace effects are challenging to estimate and require basically running the entire market in some places in a different configuration for some set amount of time. So we developed a technology we call time split experiments to solve this challenge. And just to briefly show you what that looks like, it's similar to an A/B test where we would say assign users to different conditions, but instead of users, it's time slots. So here's an example of the way that we run it, which is we have 2 weeks of, typically these tests run for 2 weeks, and we divide days up into different blocks. And then we have this mirroring and reflection approach where for every time slot that we run the treatment condition in, the following week we would invert it and run the opposite. So we get this nice randomization, but we get sort of a nice control case by using the week before or the week after as a control variable. So sort of a fun statistical challenge that we face as we start to try to build an efficient estimator for whether our marketplace changes are delivering value by running the marketplace in that configuration. All right. So all the things that I talked about all involve building a lot of infrastructure and investment in order to support them, and it's incredibly challenging to do all of these data science tasks with a high degree of reliability and continue to innovate and drive value for the company. And so on the people side, it starts with leadership and building good teams through good recruiting and good hiring practices, onboarding and training, and then sustaining a high quality data science community within the companies and make sure that people are learning from each other and building the skills that they need from watching each other work. And the data science team doesn't work in isolation. We actually partner quite closely with engineering teams, designers, product managers, people in operations. Those collaborations can be better or worse and can yield better quality results. On the system side, data scientists operate up and down the entire technical stack, all the way from like instrumenting, logging, working on making sure data infrastructure is running reliably, building and augmenting our A/B testing platform, building models and the whole model lifecycle, productionizing models, make sure they're running that they're running properly and not making mistakes, and that this evaluation and quality monitoring is just sort of like a constant investment that we make. So I'll stop there. It was a lot of text and a lot of me talking. I'd love to get to the discussion, but I hope that sort of gives a little insight into how we think about using data science to build value for the business and for our customers at Lyft.
Great. Hey, Sean, keep your slides up, actually.
Sure, no problem.
And Aaron, if you could turn my video on, or do I turn it on? So, let's just start with that was a great presentation, so thank you. And what I'd like to do is sort of just discuss some of these concepts that you brought up. So the first thing I want to compliment you on is, we do this a lot, and you've really sort of reduced the Lyft business down to its core with this, how many circles is 1, 2, 3, 4, 6 circles, and some circles and errors that we usually make fun of in academia, but it really works to show sort of what the key processes are. Every company has a lot of supporting processes, and then of course the core processes, which I think this is and I love, you're talking about sort of and then the levers. But if you were to talk about sort of the customer value proposition and the rider value proposition as two separate entities, what are the sort of the core drivers of each of those? Like, what do customers value and what do drivers value?
Yeah, that's a great question. It's worth pointing out that they're kind of at odds in some ways. So drivers are the easiest because I think they basically care about being utilized. Having a passenger in the car for as much of the time that they're driving as possible is what every driver is going for, because it's what helps them earn the most money. So for a driver, dropping someone off and then immediately picking somebody up is sort of like what we want. And that sort of happens when there just aren't that many drivers. So that when there's very few drivers, they become very highly utilized. Having very few drivers is bad for riders because it means that there's unlikely that there's a driver close to them when they request a ride. So we have to find some balance between those objectives. So for a rider, the goal is that there's so many drivers around that when they request a ride, there's somebody like almost immediately there. And that would lead to very low utilization. And so we sort of have this delicate dance to make here, where we want the market to be balanced so that drivers earn a fair wage and above an earnings threshold that we'd like to hit, but that we also make sure that the rider experience is good, that they don't wait for longer than some threshold. So it's challenging, and in some places and times it can be difficult to hit both of those at the same time.
Yeah, so that of course depends on the liquidity of any given marketplace, right? So if it's concentrated, you have a higher chance of achieving a more liquid outcome, and if it's less dense, then it's harder to sort of match riders and drivers. And then you said you focus on there's the companies running on a day-to-day basis. As you said, so when a customer presses his or her screen and asks for a car, like what are the backend processes that there's a lot of stuff that goes on, and there's some immediate optimization, which I suspect your team may have worked on in the past, but is now in the operational system. Can you give us a sense of the complexity of what is actually going on to generate a car and a price?
Yeah, that's a great question. So the first thing that has to happen is we have to price, and so you'll put in sort of a origin and a destination. We call them ODTs, origin, destination, and time are roughly the set of things that would yield. And we don't just come up with one price. We have a price for standard rides, a price for we have some high value modes where you can kind of like pay more for a nicer car, and then we have like wait and save, which is like you can pay a little bit less if you're willing to wait longer. So we actually have to create like a bundle of prices. So there's a pricing algorithm that we'll run, and you'll choose the mode by which you want to request the ride, and then that mode will turn into a request in our dispatch system. So within dispatch, we have a pool of available drivers, and we have a pool of ride requests that are made, and we're running this matching cycle. Matching cycle happens like every 3 seconds or so. We do a global optimization over all available drivers and all ride requests and try to come up with the best possible matching. We actually rematch now. So you might have seen sometimes like we found a better ride for you. That's sort of like sometimes we'll actually unmatch you and rematch you with somebody else. In order to do that matching cycle, we have to estimate how far the driver is away from you. So the ETA algorithm is what we use to do that. So for any 2 points on the map at this exact moment, we'd like to estimate how long it would take to get from one point to the other. And that's a key input in matching, because without knowing that, we would probably be dispatching drivers from too far away. So we would like to kind of like minimize the amount of time that they spend driving. And even knowing, say, like what direction that a driver is headed down a highway can help with matching, because it helps sort of like make the ETA estimate more precise. Because if we know that they have to actually get off the exit and then turn around and go back, that will take more time than getting off the exit and going to the right side of the road. So ETA algorithm is a very important component in building a more efficient marketplace. So really those are the core algorithms, of sort of like pricing, the dispatch matching cycle, and then the ETA algorithm that powers the dispatch.
And then in terms of levers, like what are the key levers that, for example, drivers respond to? Obviously, you said it's about, they want to understandably maximize their income in the amount of time they want to work that day. But part of the challenge, I guess, is getting more drivers to drive in a region in some cases. And so what are some of the things you mentioned couponing and other things that you said some run weekly, some run daily. What's going on there?
Yeah, I think the driver behavior is pretty, we think of it as pretty economically motivated. So there are ways to improve driver experience, and we do have driver centers in most cities where they can come in and get answers to questions and get their car serviced and things like that. And we do think that that's helpful, but mainly it's just sort of like if you talk to drivers, it's just sort of like how much did they earn in the last week and what is their average earning, and the earnings rate is very important. We are trying to kind of like innovate on getting people through, getting more drivers on the road means getting them through an approval process, background checks, and all that stuff very efficiently. So there's an operational burden to making sure that we can kind of take a person who wants to drive for Lyft and get them onto the road to drive for Lyft. as efficiently as possible while retaining the ability to do that safely, make sure that they like pass all the quality checks and have the right car and their car is safe to drive. So lots of stuff that like we can make more efficient to get drivers on the road. But yeah, at the end of the day, I think it just boils down to sort of like, did we help them earn money today? And we can do it in other ways besides actually through matching. Like we can help them know where to drive. So we do build products that sort of like help them say, this is the part of the city where you should head to right now because you're more likely to get a good ride at that point.
Yeah, no, it's funny because when you research in this area, I always ask questions of all my drivers, and it's interesting to me how with the taxi cab companies and the yellow, you couldn't get that kind of optimization, whereas now sort of they know the neighborhoods in which, at least once upon a time, a lot of people would go to the airport in the morning, for example. So clearly that's part of the matching algorithm as well. Quick question. So one of the things that I think is, at the center, we believe that all companies need to think like software companies. And one of the things you said when we were talking about this session, and I asked you something about like who builds the software, and you said, in addition to the data piece, you have a really, not within Rideshare Labs, but overall at Lyft, you have a very talented software team. And sort of their expertise in open source and weaving together sort of this very complex platform is done internally.
Yeah, I mean, it's all built in-house, and we do leverage a lot of open source tools, and it's a super high reliability environment. So any downtime that we have for any of these algorithms means that everyone gets the worst possible experience, which is not being able to use the marketplace at all. And so we sort of have a microservices architecture, which is like designed for really having that kind of resilient system where when things go down, we can spin up new versions of them very quickly, and we don't exhibit a lot of downtime. And then, when we build in all these machine learning models into the stack, it adds a lot of potential for other types of failures that are not really software failures, but like model failures. And so we have to be resilient to that as well. So for us, I think a lot of this just boils down to like software quality is part of the business proposition.
Yes.
And having bad quality software would mean that your customers wouldn't stick with you. They would rather go to the company that has better quality. And that also that, we as data scientists are introducing variation into this process, and it needs to be also sort of like adds a higher degree of burden on the engineers.
Yes. So I actually think there's a very fundamentally different, I used to do a lot of work on sort of make versus buy in software. And, what we're seeing with this new generation of companies is that they're all made. It's not like we don't use components that, I've looked actually under the stack because the stuff is publicly available on Lyft, for example. And there's a lot of common building blocks that we all do, but the value add piece of it is the top. Like, I have two quick questions, but there's a lot of questions. I'd rather go to, I have the opportunity to talk to you again, but one of this, a couple of the questions that I want to touch on, which I think are referred to by the audience as well, which is actually, and you just referred to it. How do you sort of monitor the reliability of your machine learning models as you sort of take them from R&D into production? Maybe I'll just throw in the second question as well. And then you have this whole shift, courtesy of the pandemic. And then obviously a lot of the past data and the data that your learning models were built on is probably no longer relevant. So if you can answer those two questions, then I'll go over to some of the questions from the audience.
COVID's a very unfortunate situation for everybody in the world, but we're learning a lot from it. I think that if there's one upside to it, it's that it's been a great stress test for every system that we've built, and a lot of things. And I think like in a way that was very informative for us. I think so monitoring models is one of the hardest things that you can do because it's hard to even know what good means for most models. And when they drift in their performance, it can be very difficult to detect. So really, I think there's a wide variety of approaches to doing it. Some of them involve more white box methods where you're trying to kind of inspect specific examples. So having a corpus of situations where the model should behave in a specific way that is known good to a human is a really useful thing to have laying around. And so these sort of like a white list of here are situations and predictions that we would expect the model to have. those things are good. We do a lot of calibration. So does the model, so for instance, for pricing, we would like the average price level for the new price model to match the average price level for the old model. So there are some sanity checks like that. But yeah, I think in general, it's just sort of like we catch problems and then we try to automate an approach to making sure that that problem never happens again. And that's a very simple sort of a methodology that it's probably the exact same thing you'd port over from like a Toyota factory. Is that as soon as you see a defect in your process, right, you stop the line and you figure out how to make sure that you don't have that defect anymore. But in general, it's very challenging also because we're shipping new versions of the models quite often, and so the comparison between an old known working model and a new model that we'd like propose as a candidate is a super slow evaluation process that we'd like to speed up. So I think that we're still early days as a whole industry in model quality, and it's going to get better over time, but it's still a lot of unsolved problems.
Yeah, no, that's, and I've been around this business for a long time, and, I was a coder once upon a time, and sort of the whole paradigm of coding from, getting it right the first time, and once you launch it, it pretty much stays static. And I mean, yes, there's enhancements every year, or you fix bugs, but sort of this is a completely different world of constant release, constant learning, improving, and you're in a very competitive market. So sort of these data-driven decisions are the difference between profit and loss. But with that, let me turn it over to sort of, because some really interesting questions here. Let's start with, how do you sort of, this is Phil Roth who talked about sort of, I think you mentioned manual overrides in the forecasting software, which is sort of related to what I just touched on. So let me try and read it. Have you built systems so they can be inputted as standard format? Are data scientists touching the data for each override, or can you accept overrides from trusted sources and have the forecasts automatically updated?
Yeah, I like the question a lot because it's come up pretty recently, is how do we do this handoff between, humans injecting domain knowledge into the models? We have a hybrid system where we the model makes a baseline forecast, we notify stakeholders, and then they have an opportunity to update a spreadsheet. So with some manual overrides, and then the model can fold them in. So it's sort of like a one back and forth between stakeholders. And to be totally honest, I think at this point we have to trust that the people who are doing this are doing it in good faith, and we do some sanity checking on their inputs. But it is sort of like challenging to monitor the quality of the inputs that we're getting. We did do a big back test recently where we tried forecasting accuracy of the model with and without the manual overrides, and the manual overrides do add value. So we sort of like know that they're valuable, and we like to facilitate including them in the model. And it does require this round trip because you have to sort of like publish a unmodified forecast and then sort of like wait for people to override it. This is for the business forecasting. For the real-time forecasting that powers the marketplace, we can't allow any manual interventions because it would be too slow to have that feedback loop.
Hey, Sean, while I read the next question, perhaps you could stop sharing so they can get a bigger image of you right now. We're both sort of, okay, perfect. And all right. How do you balance risk management, this is Lisette Highsmith, without compromising innovation?
Yeah, I think, it's always, I think it is a balance. We spend a ton of resources on testing things, because if we don't innovate, then we're not going to get better at our business. So we think of and when we run tests, we know we're paying a cost of potentially making the marketplace worse. And we do run tests that are failures all the time that make the marketplace worse. So the innovation does cost us something. And it's actually pretty hard to account for. I think we often don't really know, what are we really paying from, trying all the things that we're trying in production. But I think that there's just a culture of that this is always worth the cost, because if you are able to generate a benefit from a new innovation that you create, that you get the dividends from that from there forward in the future. So that 1 week of testing where maybe you had sort of like some suboptimal experience for some of your customers, you're getting the benefit for like many years in the future. So that's the way I think about it, is like the multiplier on a good change can be so high because you're planning for growth in the future where you have a lot more customers and a lot more volume.
So the next, how do you, one of the challenges that a lot of incumbent companies, this is a question from Mark Newen, Traditional companies, there's a lot more convincing that I think needs to go on about the value of data science, about making these investments in both compute and human talent. Um, how do you what's the conversation like at a sort of fundamentally data science company like Lyft about the role of leadership and sort of their willingness, for lack of a better word, to make the investments that it takes? Is it pretty natural, or is it still work?
Yeah, to be honest with you, I don't know how our leadership team thinks about, is this the right number of data scientists? Should we have 10 times as many? Should we have half as many? And because it's an expensive thing to add to a business. And I think at this point, the measurement of the impacts of having this many people on staff doing things is pretty rudimentary, and we don't really know the value that's being generated in specific terms. I think if you did the whole cost curve exercise, where the x-axis were spend on data science salaries, and the y-axis were like incremental benefit generated to the business, we wouldn't really know what that curve looked like. So we take a lot of this on faith, but there's a track record of multiple like wins from having like enacted new policies that were based on machine learning models that are on the order of like 25, 30, 50% more efficient than doing it in some heuristic way that we were doing before. So if you believe that you can generate something that sort of like increases the productivity of your business by more than 10%, it might be worth like almost any investment that you can make to do that. So I do think some of it's faith-based, but there is, and the wins are rare relative to like, engineering is very deterministic. When you build a new feature, it goes out and people get value from it very quickly. When you make a system better, it takes time to accrue the benefits from that. And so I think we're sort of like operating on faith a little bit, but we do have evidence that there are, anecdotal evidence that it works.
Yeah, and one of the things I used to do benchmarking studies a long time ago. One of the things you always say is, you benchmark against yourself over time. Like how much more efficient are you over processes, and what measures are important to your company.
Yeah, I think.
Go ahead, sorry.
I just want to mention, I think it's a philosophy of like, what kind of company do you want to be? If you want to go cheap on sophistication, I think you could do that. There's a version of Lyft that we could run where we say, no innovation, we just fire everybody and just run the algorithms as is. I think that's not the choice that we made. We made the choice to like continue to get better, and to do that, you just have to pour resources in.
Yeah. All right. How do you divide the work between data scientists? This is a question from Eric Moreno. Different tasks. One focuses on modeling, another on I think moved on me. Another on A/B testing, another on data engineering. There's clearly there's a portfolio of competencies that you need. And I know you had the data science team, but who surrounds you in the other parts of Lyft?
Yeah, it's a wide variety of roles that are all, mutually supporting each other. I will call out to the data engineers do some of the least glamorous work, and we really appreciate it, because there's really not much we could do if we didn't have stable systems to do the, all the backend computation and the pipelines that need to be run to support all this stuff. So data engineers, super important. Every piece of infrastructure that we spin up requires, some ownership from some engineering team and some ops team. So like, there's just like an incredible amount of supporting work that needs to get done. And a lot of data scientists might not even really know that there's like a team of dozens or even hundreds of people required just for them to be able to run a query and train a model. But that's the fact of the matter, is that like there's a high fixed cost to running a data science operation. There are roles specifically within data science. So there's some further heterogeneity, like even within the science role. And so at Lyft, we have two kinds of data scientists divided into three tracks. So we have a algorithm data scientists focus on decisions that are made by machines, and decisions data scientists focus on decisions that are made by humans. And that's a kind of a little bit of an arbitrary distinction, but it's useful for us to help sort of segment the work a little bit. And A/B testing falls into the human decision making, whereas running a new version of the pricing algorithm would fall into the algorithms version. And then we also have like operations, research, and optimization experts, statistics and machine learning, are different tracks that we kind of like have crafted to help make sure that those people are working on the right projects and get matched to the projects that are the best fit for their skill sets.
So a question from Michael LaFontaine, which actually follows what you just talked about. What's the strategy for attracting and retaining talent? Because It's really hard, obviously. Should you be near, and there's a sub question, should you be near technology hubs, or do you try to draw them to the company based on perks?
Well, I mean, Lyft's based in San Francisco, so we do the same thing a lot of other tech companies do, which is, try to exploit those agglomeration economies as much as possible. And it is a very hot job market for data scientists, and they do switch jobs a lot. And I think it's been a real challenge for the industry because there's always a cooler company to work for. So we try to attract people based on the quality of the people. So we have a lot of talented people to work with and people to learn from, and the quality of the problems. So there's interesting things, and we have not everything at Lyft is a solved problem, and there's lots of opportunity to have impact. And then all the other stuff that you would choose to work at a company for, the culture, the believing in the product and the mission, all those things are important. But it is, I won't lie, I think that we have a really hard time with talent in general because there's so many great jobs for data scientists out there. One strategy that we do try is to have a more public facing view of what we're doing internally. So we have a blog where we try to write a lot of what I'm talking about. You can go and read blog posts about in much more detail than what I'm talking about. And we're very open about the work that we do because it signals that it's the kind of place where, as a data scientist, you can talk about your work and that what you're learning at the job, you can actually go and take with you to your next job. And so that you get to kind of appropriate some of the gains from the learning that you're doing. And that's important to data scientists. It's a job that depreciates rapidly. Your skill depreciates rapidly. So the ability to continue learning and to take that learning with you further down the line in your career is, I think, something that is an important philosophy.
Now, a very specific question from you guys work on rider churn?
Yeah, of course. Rider churn is an important source.
How can data science help?
How can data? Yeah, ultimately, every problem that you have as a business, you have to have a lever of some kind, something that you can do to have some causal effect on it. And so for rider churn is actually one that's quite challenging. So if people leave the platform, we might not have any ability to ever, re-engage with them again. They might not have the app anymore. They might have turned off email. So we have no tools to get riders back when they've fully churned. And so a lot of these things boil down to sort of generic policies around how do we make riders happier. And it turns out the easiest way to make riders happier is to just give them good service levels and low prices. And so a lot of rider churn problems actually translate quite directly into rider experience problems. And can we make the product better for them? And ultimately, a lot of our tools for making the rider experience better boil down to market balance, which is what I talked about in the slides. So thinking about what is our policy space is things that we can spend money on, new features in the app, emails and communications with people, incentives of various kinds. It's actually not a wide variety of things that we can do. A lot of the bottleneck in solving problems is just sort of we as a company only have a handful of tools at our disposal to make the product experience better so that people won't churn.
Yeah, that's an interesting comment because it ultimately does boil down to the levers you have. So there's a question about when you have drivers who drive for just Lyft or Lyft and one of its competitors, how does that add a random? The question from Bill is: it seems like this would add a random complexity. How would you account for the situation in matching drivers with riders?
Yeah, so drivers are considered to be idle for Lyft, and that's the state that we can kind of create a match for them. But they may be idle for Lyft and for Uber at the same time, and so they might choose to take a ride that they were matched to on the other platform. And so this is sort of just a source of errors that we can make. It's very difficult for us to know, whether they're engaging in this, and so it's sort of something that I think we probably could have more sophisticated solutions to than we probably do. But the matching cycle stuff is quite resilient. So if we're not able to match you to a driver this cycle, or the driver cancels, you get a driver as soon as we can. And so mainly we rely on the system to be resilient to these things just through sort of iteratively rematching, rather than sort of any sophisticated understanding of what the driver's intentions or sort of latent state is. But I agree that like the fact that we operate in a market where both the riders can check both apps and the drivers can check both apps makes the whole business like a lot more complicated.
There's several questions, so I can't really name the Michael LaFontaine and some other questions too. Like in terms of sort of the sensor data, both within a car or from the highway, is there anything that you're doing that's collecting sort of external data that you can use from, like I said, from the cars, from the road, from whatever sensors out there?
That's a good question. I might have to punt on that one. I think like we have the GPS data from the car. There's from the phone, and there's some accelerometer data in there, so we know about acceleration and it's direction that people are headed. And we use this to make sure that we do a thing called real-time map matching, which is figuring out like what road segment that a driver's on, and that algorithm uses like every sensor in the phone is being applied to make sure that that problem is well solved, because not knowing where the driver is a huge problem for us. But I don't know about external data. I think we do kind of map quality data is an incredibly important input to our process, and OpenStreetMaps is what we use for our maps, and we contribute a lot of edits back to OpenStreetMaps. And so making sure that our map is up to date and reflects sort of like the current state of every road segment is actually one of the more important problems, because our ETA algorithm relies on that to know like, oh, the driver could get there because that road segment exists. So that is a very important source of external data that we do use quite extensively.
And then there's a specific question from Kanan. With regard to the ML tools, you use commercially available tools, or are these all homegrown, open source?
I mean, I think like any company, there's a variety of pieces of software. I would say the Lyft, like GitHub, probably has on the order of thousands of software packages in it that are used for small bits of functionality. And some of them are open source, some of them are not. And ultimately, like the real interesting bit is how we compose all those tools together, and that's the real value that we generate. So Lyft open sources a lot of what we work on, because it's not really like the software isn't the business, but we also sort of like we pay a cost every time we open source something, because we have to go and then support it with the whole community. So there's lots of trade-offs in like build or buy, or build yourself and then open source, that we're kind of constantly navigating. But yeah, I think that in general, like you can't build a platform like Lyft without a ton of open source stuff, but you also can't open source everything that you build. And
then sort of the choice between upskilling employees for sort of AI ML capabilities versus sort of hiring talent with experience skill set. I suspect you do both, but if you could talk a little bit about the hiring.
Yeah, that's the clear answer to that one is you have to do both. And then they mutually reinforce each other. When you bring in smart people, they can help upskill the people that are on the team. Sorry, I forget the second part of the question.
So the question was, maybe I made it into two parts. It's actually probably just one part, but the idea was, do you hire experienced people only, or do you also upskill?
Speaking about the hiring side of things, attracting really top talent is the hardest part. I think there's a set of data scientists that I think are the kind that teach other people and mentor them and help bring your company into the future and certain technologies that you don't know a lot about. So a good example would be, there's not a lot of people at Lyft who have deep learning expertise, and it's relatively rare, because the company hired a lot of the data scientists before that became very hot. And now we would love to invest more deeply in deep learning, but those people have great jobs at other companies by now. So we are trying to make up a deficit there, and it's an important investment for us to kind of modernize our approaches as much as possible. And so yeah, we do strategically try to hire people who have, I always call it, and this is a little jargony, but expanding the convex hull of your skill set at your company. There's certain gaps and skills that, if you get somebody who can apply that skill, they can teach other people. And it really does, it creates a whole new space of solutions to problems that you don't currently have. And so we do try to identify that. And yeah, deep learning, reinforcement learning are all kind of areas that we're kind of aggressively trying to staff up on right now, because we think of them as like potentially, step function improvements in how we're working.
Yeah, one of the things I'd like to actually advance to sort of the audience today is because I think these, like deep learning is showing its value in protein folding and, far outperforming university biochem departments and so on. And today I read a really great story about how, there's a new company that's been launched that is targeting property and casualty insurance because apparently like big disasters like wildfires are not easily covered. And so business interruption risks, which we're all experiencing as we speak, and so they're trying to develop a big data science approach to business interruption insurance. And so I think the point of what you're saying is as you get more and more sophisticated techniques or technology and technologists into your talent pool, I think you can solve sort of more complex problems. One is sort of a interesting question, and I've heard it before. Like, where should a data science organization sit within a company? This is Glenda. Should it be within the IT organization? And some people believe it should be in the business, somewhere straddling to. Clearly, this is sort of an intermediate role. I mean, not an intermediary role in most companies.
Yeah, it's a hard question. I think that there are trade-offs no matter how you do it. I think having the good leadership is really the key. Like whoever it rolls up to, you have to have somebody it terminates in who really believes in the value proposition of the data science and is willing to fund the work through making sure that it's well staffed and that it has all the resources that it needs. And so like I think that the person at the very top believing in it and investing in it is really what I care about the most as a working data scientist. The collaborations with the cross-functional teams I think kind of end up working out on their own regardless of the organizational structure, because there's just so much at least I've worked at two big tech companies, so maybe not the largest sample possible, but you always have to work cross-functionally. There's never one project that can be done by just one pillar of the organization. Even engineers can't do things unilaterally. They need product people to help inform the roadmap and how it fits in with the rest of the strategy. They need designers to help figure out what it's going to look like for users. They need UX researchers to understand and be the voice of the customer. So there's just like almost every project at both Facebook and Lyft that I've worked on is a collaborative project across multiple pillars. And what team or pillar that they roll up to is often sort of inconsequential for the project that's being done. So for me, I think like where it sits in the organization is wherever it will get the most resourcing and the biggest belief in its potential.
Yeah, and that's a really hard organizational challenge because younger companies like Lyft are built around sort of being software powered from day one. And I think it's a little bit harder for existing companies, or a lot harder with, built-in incentive system. There's several questions here about sort of what happens once sort of you've decided that your model is working well, and sort of how do you partner with software teams? How does a model go into production really?
Yeah, it's a long-term process. I was just reflecting on something that a project we started about a year ago. It's just finally was tested like the first time in like November, and now we're running like another test in just now at the end of January. So it's like 6 to 8 months of time between idea to like offline model results to getting it integrated in with the production algorithms. And there's just sort of like a set of phases of model validation. And probably the most interesting one is there's a hybrid between offline and online where what we call shadow, where we run the algorithm normally and we don't change the user experience at all, but we log what would have happened if we had run it according to the machine learning algorithm. So for the matching algorithm that I described for dispatch, we can log like, hey, if we had used this machine learning algorithm to do matching, here's what we would have allocated. Here's the driver that this person would have gotten. And it's complicated to analyze that data that comes out of that, but we do try to do a good job of saying, well, assessing the shadow data to understand what the risk is. And then if the shadow data looks good, we can actually almost all of our algorithms have the ability to do like a hybrid policy where we can do like an average the production algorithm and a new one, or we can flip a coin and do one or the other. So there's an ability to sort of like interpolate between the old policy and the new policy to make it safer. So there's lots of options for sort of gradually rolling things out and trying things. For us, we can try things in a small number of regions or in a smaller region that's less risky. So there's ways for us to sort of like, get a model into production and then actually try it in a real market context that don't involve launching it to everybody and incurring a ton of risk. But that playbook, even the point up until where you get it into shadow, is actually quite a long journey, because there's just the integration stuff. Going from a prediction to a decision is actually quite a complicated thing. There's lots of heuristics and filters that need to be built in. It's never just like the machine learning model spits out what to do. It's just an input into like a larger system.
As I hear you talk, because you guys are innovating so rapidly and adding features to your platform, there has to be sort of the architecture is just crucial, because you're actually plugging in new modules on a fairly regular basis, right? On all aspects of the business.
Yeah, there's a real art to getting that right, where if you get it right, you can be really agile, and if you get it wrong, then everything is a really high engineering cost of integration. The key idea there is that any change to your models or parameters of your system should be configuration, not code. And if you can make it so that it's configuration, then it unlocks a whole lot of ability to test things really quickly. If changing things requires shipping code, then it slows things down a lot. It makes everything a lot riskier. And it's a big principle at Facebook and also at Lyft to just sort of favor configuration over code as much as possible, because it sort of like makes every version of Lyft is just like a file that you can change, and all the backend stuff that supports that should be interchangeable and relatively standardized.
Yeah, and that's much harder, obviously, for legacy organizations. I'm going to sort of close the last question for you with some advice for, a lot of companies in our audience are not as sophisticated as the Lyfts of this world. So if you're trying to get started in data science, and not in data science, but build a data science organization, like what are some common mistakes, some sort of advice that you can give people getting started?
Yeah, I think that I have to sort of extrapolate here, because I haven't been the first data scientist at a company before. But if I had to do it, I would start with your single hardest problem that you think data could be useful for, and try to envision what a small change to that would be that's feasible within some amount of time. I think big ambitious data projects are always at high risk of failure, and data scientists that don't have specific applications or scope to improve the business in some way are going to flail around and not be able to make progress. So when you have a clear mapping between the data scientists and some thing that they have to change and improve, and that thing is important for your business, and you give them the resources to make sure that happens, such as the engineering support that they need, then you can unlock a lot of value. But you really need the confluence of all of those things, because I think just hiring data scientists isn't enough. Just having data isn't enough. It's really sort of like all those balls have to line up.
Great. Thank you so much, Sean, for a fantastic presentation. I'll just take one more minute to wrap. So thank you all to the audience for your wonderful questions. I don't think we've gotten more questions for any of our events than for you, Sean. I sort of feel bad for the people that I couldn't get to. I was desperately trying to read as many and combine them into sort of complex questions, but there's still 24 questions that I have not been able to get to. So thank you for bearing with us. We will hopefully try and bring you more events where we can try to get some of these questions answered. I just want to close with a couple of things. So first of all, Sean, thank you very much. That was absolutely fantastic.
My pleasure.
I want to remind everybody that we have another wonderful event on February 23rd. It's Nicole Perlrott from the New York Times. She's one of the lead cybersecurity reporters, and she's got a book coming out in the next couple of weeks. It's called "This Is How They Tell Me the World Ends." And as you've all been seeing with the SolarWinds thing and the attacks on sort of U.S. government institutions, cybersecurity is just is getting to be a bigger challenge for more and more organizations. So if you can join us for that one, it's on February 23rd, 5:30 to 6:30 p.m. Thank you all for your attention. Thank you, KPMG, for making these events possible. And once again, Sean, thank you again for joining us. We know how busy you are, so really appreciate it.
They were great questions. I really enjoyed it. Thanks.
Yeah, thank you all for attending. We just love you joining us at all our events, and thank you for your participation. We couldn't do this without you.